In this video, we're going to look at what's called relative frequency. If you had, say, 50 people in a class, and 45 of them passed the class, well, the frequency of those who passed would be 45. But the relative frequency, written as a fraction, would be 45 over 50, which is really 90%. So the relative frequency of the people passing would have been 90%. So let's take a look. Students in an economics course were given a quiz and had just one multiple choice question. 5 choices, A, B, C, D, or E. This frequency table right here, to the left of this line, response and frequency, shows the frequency of the responses. So 6 people chose A, 14 people chose B, 8 people chose C, 22 chose D, and 10 chose E. So what is the response relative frequency? Well, the first thing you need to do is count up how many people were in this class, which we could do right here. Let's see, 6 and 14 is 20. 8 and 22 is 30, so that's 50. So we have a total of 60 in the class. I'm going to have to get my calculator out here. If I want to write it like a percentage, I have to. Well, the relative frequency, first thing I'll do is write it as a fraction. Write all of them as a fraction. So we've got frequency of 6 means the relative frequency is 6 over 60. Well, that's 1 over 10. I know what that is. That's 0.10 or 10%. You don't have to write it as a percent. You could use 0.10. These all three are equal, but I think most frequently we use a percent. And then this one's going to be 14 over 60. This one's going to be 8 over 60. This will be 22 over 60. And this will be 10 out of 60. All right, so I'm going to have to decide what I'm going to do. I think I'm going to go out 2 digits. For example, 14 divided by 60 gives me 23.3%, 23.3 repeating. So maybe I'll just go out to 0.23. It's 0.23 repeating. I will write that like 23.3%. So I essentially rounded it, but I went out to the 10th place. And the next one is 8 over 60. 8 divided by 60 is 13. Let me write this. It's 0.13 repeating, which we'll call that 13.3%. If I wanted it exact, I would put 13.3 repeating percent, but I'm just going to round off to that 10th place in the percentages. All right, so now we go to 22 divided by 60 is 36.6%. It's actually 36.6 repeating. Or 36.7%. I'm rounding up because it was a 6. 5 or more, you'd round up. And finally, 10 over 60, that's 1/6. I know what that is. That's 0.16 repeating. Or 16.7%. Okay, so these are our 5 relative frequencies for each of the responses, A, B, C, D, or E. What we're going to do here is just do another histogram. But instead of using the actual numbers, we are going to use the percentages. So let's just say right here, this is 100% at the very top. So maybe I'll go with 50 here, 50%, and then 60, 70, 80, 90, and 40, 30, 20, 10. 10%, 20%, and so on. You can fill all those in if you'd like. And then I've got 1, 2, 3, 4, 5 categories. So I don't need to write ranges here. All I need to do, because I don't even know, this is, all we're going to do here for the category is put A, B, C, D, and then E. And we may have to kind of estimate, between 10 and 20% and so on. The first one's easy, it's 10%. We have 10% that chose A. And I actually did not have to go up to 100%, did I? I actually only needed to go to, what's the highest one? 36. I would only had to go to 40%. Nothing is going to be higher than 40%. And then B is 23.3, so a little bit above the 20% line. And then C has a height of 13.3, which is a little above 10. Yeah, I should have stretched these taller. I should have gone all the way up here just to 40%. Then D is 36.7. That's almost 40%. Up here, not quite up to 40%. And finally, E is 16.7%, between 10 and 20, a little closer to 20. So we'll go to there. So what this tells you is if you add up all of the heights of these bars, you would get 100%. And on occasion, you'll see in the diagram, the actual percent. Because again, I didn't get out a ruler. I just estimated these heights. So B, 23.3%. C is 13.3%. D is 36.7%. And finally, E is 16.7%. That's purely optional to do that. And again, I want to remind you, it would have been nicer, there would have been bigger differences between the heights if I would have only gone up to 40% instead of 100%. Right here I put 40%, should have just stretched that way up to here. But you get the idea. This is still valid, it's still accurate. Well, it'd be more accurate, I think, if I did it the other way, but it's still good. So this is a relative frequency histogram. The only difference being that we use percentages here instead of heights like 6, 14, 8, 22, and 10. Okay, let's look at pie charts. Pie charts are used to show a proportion of data that fall into given categories. It's similar, in that respect, it's very much like a histogram, a relative frequency histogram. The entire pie would be 1.0, or more likely we think of it as in percentages, 100%. So I'm going to try to draw a good circle here. If that's my pie, it represents 100%. If I draw a diameter right down there, we get 50% on each side. And let's say instead of writing 50 over here, I'll break that one in half. These would be quarter pies, 25% each. Like so. That's what a pie chart looks like. All right, so number 10. A student, Bob, has $200 to spend this month. This table right here is basically his budget. This is everything he needs to purchase, and if you'll notice, this adds up to $200. We're going to create a corresponding relative chart that shows the percentage of the $200 that goes into each category. So it's a relative pie chart. All right, the first thing we're going to do, let's figure out the percentages here. Since it adds up to 200, On dates, he's going to spend $70. What's that relatively speaking? If you think of his whole $200, that would be 70 over 200, which would be 35 over 100. So if you just plug this into the calculator, you're going to get 0.35, which is 35%. All you have to do, since there are 200 here, divide these numbers by 2, and it'll give you the percent. So books is just 20 bucks. So 20 over 200, that's like 10%. It's equal to 10%. Laundry is, laundry is 10. So relatively, that's 10 over 200, and that's going to be 5%. Bicycle repairs is $48. That's going to be 48 over 200, which is 24%. Miscellaneous, $52. 52 over 200 is 26%. Now, we need to, I don't want to get a compass and protractor out here and get exactly the degrees. I'm going to estimate here, but let's do the best job we can. First, draw a nice circle. It's one of the better circles I've ever drawn. Okay, I'm going to put a dot just where the center is, and maybe I'll just start a line going straight up like that. Now, where would we want to start? Well, notice a couple of things. Notice that the first three add up to 35, 40, 50%, which means the bottom two add up to 50%. So I certainly know that I'm going to need to divide this circle into halves, just like that. All right, I'm going to do the bottom two first. Look how close they are to 25, 25. It's not going to be like a quarter circle. I just need to go up a little bit, something like that. Notice this one is smaller, so this will be the 24%, and maybe I'll write, I'll label it. I'll put bike repairs. And that's going to be 24%. And then the 26% was miscellaneous. I'll write MISC, and that's 26%. So those are actually probably pretty good representatives, because we know that the two of them together represent half of the circle, 50%. So now what do we want to do? 35%. That's bigger than half of this half, a quarter of the circle. So maybe I'll go down like this for 35% right here. Remember, this half circle is 50. So this will be 35, and this would be for dates. 35%. And now this rest of this makes up 15%. So 10 is twice as big as 5, so make one of them twice as big, roughly, as the other. So let me see if I can squeeze laundry. I'm just going to put a capital L there for laundry, and that's 5%. And then books is 10%. So this is a pie chart, and more specifically, it's a relative pie chart because, and that's what most of them are. They usually have a percentage, and just remember, the entire circle, the entire pie must add up to 100%, as this does.